Thank you. And like I said, I'm Guto Maia, and I'll be presenting PyNES, which means Python programming for NES. But for the ones that were present since the James Taub's presentation, that presentation could also be labeled as episode 5. The 6502 strikes back. So let's start with, OK, long time ago, I've done a lot of crap with the 6502. I've done an assembler compiler, an image sprite importer, a namespace importer, a lot of things, and though this is all technical things that I'm not here for this. In fact, I do hate topics. So let's do a different approach for this presentation. Instead of showing topics and technical stuff, I'm here to explain more the philosophy behind the PyNES. So we are trying to do a parallelism in the name that it stands for. It will be more like, for the ones that knows that, kind of Hebrew poetry. And since PyNES stands for Python Programming for NES, let's try to find out a parallelism for programming. I can imagine the action of programming without thinking about compilers. In the history, compilers usually have evolved and shifted along with the CPU architectures of their time. Take C language, for example. It was designed, aimed for the PDP-7. It was formalized in the way that all transitions were documented, and for every high-level instruction, there was a set of low-level instructions for that. So, however, at the x86, the C compiler had to find new optimization patterns. The C language itself, the language doesn't change, but compilers had to change to better fit the new CPU architecture. For example, a friend of mine have tweeted me, OK, in Portuguese, so let's press SAP. The GCC generated an opcode. What the hell? When I was younger, opcodes have 2 digits. Can you imagine what this opcode means? This opcode is in the AT18 platform, so the equivalent in the Intel platform is this, and it means that convert a scalar double precision floating point value to a signal double word integral with truncation. OK, therefore, there's a bunch of pattern matches in order to do optimization. Some of them are not formal. Why not do the other way around? Instead of making language fixed, like C was, C is fixed, and using pattern matching for optimization on the CPU, I use a fixed CPU, the 6502, and using pattern matching to allow high-level language to deploy on a very limited architectures. We can do that. So I will define programming as translate. And OK, we are at PyCon. Let's go for Python. Every time that I hear Python, I think of Pythonic. I think of the Zen of Pi. And every time you heard that, we have a different way of programming it. We don't like to write Python code with Java accent. It's strange. So I also didn't want to create a framework. I want to respect Python and the NES. I want to create a idiomatic Python code that must translate into a idiomatic NES assembly code. Someone that really a code that a NES gamer or NES developer would write. So I didn't want to be agnostic. In fact, agnostic comes from Greek, which means that denied knowledge. So PyNES is Python. And yes, it is a hack. So I do translate Python into respect. I want to be respectful with Python and with the old NES developers. So what goes for the NES? OK, is the Nintendo 8-bits. It's a very limited hardware. I mean, not limited today. I mean, it's limited at their time. At the way when it was launched, it was already limited. It used the 6502, which James have already shown some aspects and how it works in the presentation before. So at the gaming aspect, it was only using usually 48 key for code and graphics. It's very low. And although it have a nice palette at their time, it can only use small sprites with 4 colors. And that's alpha included. So can you imagine how the sprite AP, yes, was? In fact, there was no API for the Wix. Everything is memory address. The same way you access this video processor, the sound, and your program routines are the same. You just put assembler. And yes, it does have a PHP instruction. So you get the feeling of the taste of metal thing. Every instruction you write goes direct to the processor. In fact, the cartridge is directly connected to the processor. But there's no way with calling about a platform without saying something about the software that was built for them. So Nintendo was well known by the software they have. So they have 8D games, I mean, head-then games. And they were always on hard mode. Doesn't matter what you do, they are always on hard mode. I come from a generation in the 80s that was really defined by the word of frustration. You mean, those games are not meant to be finished. They were like more a path of persistence, a test of resilience, and the only certain truth is you are going to die. I mean, you are going to die a lot. And help, there's no help. There's no screen tutorials. Nowadays, even FPS, they have tutorials to show how to shoot a gun. What the hell? It's an FPS, you have to shoot something. But how it happened back then, there's a gap, you didn't jump, you die. There's an enemy, you didn't kill, you die. You have a project, you didn't avoid it, you die. Oh, you did something wrong, you die, have fun. Nowadays, you have the concept of replayability. Oh, what's that? It's not like today. People now reach and collect trophies like Java certifications or something like that. I don't know what the hell I was trying. But back then was kind of a different way of doing replayability. Despite the number of players' lives that were taken, those games were great, and they were really great. So beyond the limited hardware, there was unlimited creativity. So a hardware constraint doesn't limit your creativity. And NES is for sure really Spartan. I mean, Spartan in the way it is. It's very simple, it's very well made. And it's Spartan that it can even now kick any other console into the pit. And I would define for NES into simplicity. So a parallelism for the PyNES is respect translated into simplicity. So PyNES is done in Python, in the NES way, with no round corners, and you get hurt. So let's go show them. And let's hope that everything goes well this time, because I must... Okay, you're now seeing my screen. And I've done some presentations before, which I have to rearrange the windows, but okay. At the left screen, we have the code that I've done in Python, and the right screen is the assembly-generated code. So to avoid just to be typing here, which didn't work in the previous presentation that I did about this, I will try to explain the code. So I have just defined a palette. The Nintendo, you need to define a palette. And since I have created a sprite from this file here, and since it has a different architecture, and you have to put anything in the PPU, in the graphic processor, right here, you are loading the sprite, okay? And in the joystick 1 up, you are getting the sprite. When you load the sprite at position 0, you're loading the sprite in the PPU. When you're getting the sprite, you're getting the same sprite at the PPU. So let's just save the code to make it work. You see that the assembly code will kind of change it. And let's load it. Oh, sorry. Must be the one called output. Okay. You have a NES demo. So what I try to achieve with PyNES, I really try to do it in a different way. Instead of making safe transitions and know every single transition that I want to do from source to the compiler, I try to fill the gaps I found on the internet. And in this case, a friend of mine, Klaus, he made this demo in assembler, and I try to figure out how I would write this demo in Python. So I write the demo in Python. No, just I have to make a bunch of tests to make sure that the way that I've written the demo in Python must compile at the same assembler. It's crazy because it's really a hack the way that I'm doing. So let's make some changes, and instead of sorry. I have just changed the file that I'm loading, and since everything, oops, it loaded a new sprite. And when I move, yeah, like I said, I don't try to be agnostic. I'm not trying to hide the Nintendo that it's. So when I loaded the player sprite, I load kind of 8 sprites. But when I'm doing the get sprite right here, I'm just getting the sprite number 0 at the PPU. But I can get the player reference instead of getting sprite 0. And let's hope for the best. The funny thing about doing live code, it's make you blow into your face. But sometimes it works. And guys, I'm kind of open for questions. I really try to run things. Guys, are you all afraid?
So back in your code there, you're loading the palette, you're loading the asset, but I don't see where you're tying the asset to the sprite. Is the asset just a magic global variable there, or?
I just don't use it in this case because it's kind of a global variable because I have some tricks that I'm trying to use the access to change. I want to switch that specific asset. But at the end of the code, if I know, there is a variable that is in the global scope that is attributed with the type NES C8R file. Defined that variable has this kind of type of structure. And at the end, it will say, that single import here generate, let me see if I can, let's generate an instruction at the end, calls this ink bin player CHR. You see? In case, he will be Mario CHR. Every time, if I remove that, the code is, the rest of the code will be the same. Because even though you don't have the variable, but at the NES card, it will be kind of a memory dump that it's empty. You will get like a blank screen, and you are trying to move a blank screen in the screen, so you just won't see it, but it's kind of work the same. I'm not sure if I'm really clear. English is not my mother language. Sometimes it's hard.
Can you show how you do the translation?
Can you repeat the question for the video, please?
Sorry, could you pass the mic?
Can you show us? Can you show us how you do the translation? How you organize
the code behind the
Yes,
demo?
I can show some part. It's kind of complicated because even now in the conference, I met some guys that are kind of doing the same, but what I'm doing is I'm using the AST and node transformation node visitors to redefine the language as it's running. So I have my composer and I have my like I said, the way that I'm doing is kind of a hack because I've made the Python example before the compilers try to compile itself. So, like I said, I'm trying to figure out a way I would write that NES assembler that way in Python. So, what I've really done is several tests that would allow me, that example must have this in the composer. And the composer right now is a completely mess, as it was supposed to. It does several transformations, some kind of visitors into every single part of the Python code. And some parts they have lots of to do, fix this, fix imports, fix something. Because I figured out, the way I'm doing, I will not be able to do NES scrolling properly. I will not be able to do check for collisions in the way that, in a more Pythonic way. I would do it more like a hack way. So I do have, there's a lot of code that needs to be refactored. But what I do believe in the way that I'm doing is, since it's kind of a pattern matching thing in the way that in the Python, is that the design will emerge from that. In time, the design will emerge until I reach a goal. The goal that I'm trying to reach is to write a completely NES game in Python. When I reach that goal, I believe that, for me it's finished. If someone wants to carry on, go forward.
How NES specific is your code? Do you think it would be feasible to use this to actually translate Python to 6502 code that I could run on Apple Pi?
Yes, I think that is possible. The problem for Apple Pi is that I create a container that's called the game. The cartridge, the NES cartridge itself, it's a hardware with mappers, with specific ROM cards, ROM chips attached to it. So for emulators to be able to run games, they created a specific INES header to define the way that NES files should be. So that game aspect, they try to, I have this game aspect that will define the high-level part of the game, and I have the INES part that define, that's the way the cartridge is. And the only problem is I do have to specify a way that's the way that Apple program is. There's...
yeah, is this working? Have you built any, do you have any like open source examples with some of the sort of higher level constructs that we remember from NES, like levels and collision detection, things like that?
I have some low level. I don't have some high levels. I'm trying to figure out the way that I would write them, but...
But you have examples with the like low level examples of that?
Yes, I do, but they're not here.
Okay.
They're not ready for the presentation.
Sure.
I just try to figure out. In that example, I'm more exploring some core aspects of that, because every game, every NES game must have like they wait for the VBlank and clear the memory and something, and some part of dealing with the input handling, but not much of the collision detection. But I've already also, as said in the first slide, in the first topic slide, along with the compiler itself, I have done a tool that allow me to import sprites and convert sprites and also name tables from image files. So one good example is the one that I presented at the Python Brazil that showed the logo and also invites everyone for Python Brazil. That's one for the Python Brazil 8, but I think that still got the same invitation for the Python Brazil 9, which will be this year.
Any more questions?
I think that's let me just get back to the slide.
Excellent.
And, well, thank you guys. My name is Guto Maia. This is my mail, Twitter, and I'm not sure if it's really over, but I must say that I bought a master system.